Hey there, this is Ken and I's dad. I'm trying to help you out with this exercise you're working on. All right, so it looks like you're working on function stuff. All right, so um, let's talk about this for a second. So first of all, let's answer the question, what is a function? Now I could get into a bunch of gory math stuff to explain it, but I'm not going to do that. Think of a function as like this little black box, okay? And it's got a little funnel on the top and a little conveyor belt that comes out the end of it. And you put something in the funnel, you turn the crank, and something comes out on the conveyor belt. So we have the input, which is the funnel. We have the output, which is the conveyor belt. That's really what a function is. And that black box, it could be an equation. It could just be a relationship like what you have here. So what are my inputs? Now, at this point, you're probably familiar with the rectangular coordinate system with X and Y coordinates. So remember that these ordered pairs, we call them, your X is always first, your Y is always second. This X, we call this the independent variable. It's also, for our purposes, we're going to call it the input, okay? The Y is our dependent variable, and we're going to call it our output. So if we look at our little black box that has the little crank on the end of it, and there's a little funnel or a hopper here and a little conveyor belt that comes out the end. Our X goes in here, our Y comes out there, input, output. So in this case, okay, for example, if we had a function, let's say we had this function, f of x equals 3x plus 1. Well, x is our input. So if we put in an x value of, say, let's let x equal 3, well, all that means is we're just going to put 3 as our input, and we're going to dump it into the hopper, turn the crank, and see what comes out. Well, here, this is our 3x plus 1. So 3, and this 3 is going to replace the x plus 1. That's going to give us 9 plus 1, 10. So the output here, y, has to equal 10. So f of 3 in this case equals 10. Well, that's all fine and good, but what does it mean for what we're dealing with up here? So basically what's happening is actually much simpler than what's going on here. Basically what this tells us is if we put a 5 into the box, we're going to get out a 7. That's all we need to know. If we put in a 4, we get out an 8. If we put in a 5, we're going to get out a 10. We put in a 7, we'll get out an 11. Put in a 9, the output is 14. All right, so let's talk about part A of the question here. State the domain. Well, what is the domain of a function? Okay, the domain of a function is simply all of the x values that produce an output. So basically, the domain of a function is just, it's just all inputs, okay? The range of a function, well, okay, so let's think about this for a second. If all of the x values give us the domain, then what values give us the range? Yeah, it'd be the y values. So the range of a function is all of the y values produced by the function. Or we could just say all outputs. Okay? So going back to part A of your exercise here, state the domain. Well, we just said that the domain is all of the x values. So using set notation, we're going to say it's 5, 4, well, we've already got a 5, 7, and 9. But really what we should do is let's list these in order. So 4, 5, 7, 9. That is the domain of your function. If you want to write it more formally, we would say x such that x equals 4, 5, 7, 9. Okay. That's the domain. Well, the range of a function, we just said that that's all of our y values. So I should have thought this out a little better. So follow the arrow. The range of the function, well, we're going to have, let's see, 7, 8, 10, 11, 14. Okay. Or we could, to be more formal, we could say y such that, and this little line is math shorthand for such that, y equals 7, 8, 10, 11, 14. All right. Now, so that's part A, that's part B. We got those taken care of. Is this relation a function? Okay. So let's talk about what is a function and what is not a function. In order to be a function, it has to meet a certain number of criteria. Functions must, okay, have no more than one output per input. Now, that's kind of a layman's way of talking about this idea that we call the vertical line test. So let's take a function. Let's just go ahead and make up a function. I'm just going to draw a graph here. This is my y-axis. This is my x-axis. And I'm just going to draw some basic function like this. Okay. Now the vertical line test, what that does is if we were to run a vertical line along the x-axis like this, right? If we were to run a vertical line along the x-axis, our vertical line will only cross our curve or our graph. It will only cross that curve at one place at a time. So if we drew a vertical line, let's say here, well, it only intersects the graph once. If we drew a vertical line here, it only intersects the graph once. Okay, so this passes the vertical line test, and therefore it is a function. Now let's look at another scenario. If we do another graph here, x, y, what if we had a graph that did something like this? And then if we tried to do our vertical line test? Well, if we do a vertical line test here, we have, for that x value, whatever that x value is, let's call it x equals -3. Well, at that value of x equals -3, it's going to give us a y value of whatever that is, and whatever that is. So for each input, and remember up here we said that our inputs are the x values. So for this given input, slide my paper up. For this input of x equals -3, you end up with 3 separate outputs. Dude, we just broke math. We can't do that. So this is not a function. So let's take this understanding and apply it to your original exercise. So given this relation, and we've got 5 ordered pairs here, for my input of 5, I have an output of 7. Okay, so I'm good. 1 for 1. 1 output for 1 input. 4 outputs an 8. Okay, we're good. 5 outputs a 10. One input cannot give us 2 different outputs. Cannot happen in order to be a function. So what happens is, if we were to actually graph these points, and let's do that real quick. If we graph this, and let's see here, I'm going to run out of space, but we'll try to make it work. So we have, let's say we have 5 and 7. That's our first point. Then we have 4 and 8. That's a point. We have 5 and 10. Put 10 up here. Well, right there, you can see that we don't need to go any further, because this group, this relation that they've given us fails the vertical line test. We have one input that tries to give us 2 different outputs. So this is not a function. And to answer the question, which coordinates caused this? Well, the coordinates that caused it were 5 and 7 and 5 and 10, because in order to be a function, we cannot have one input give us 2 different outputs. Fails the vertical line test, therefore is not a function. All right, I think that should clear it up for you. And if you run into any more questions, just have Ken and I give me a shout and we'll get you squared away, buddy. Talk to you later. Bye.